Right, good day to all my wonderful online viewers. Just to remind you, if this is your first time of watching this YouTube channel and you have not subscribed, it won't cost you money. Just press the subscribe button, strike the bell also for notification of other videos, and other videos when they come on board you'll be able to see them. Thank you for viewing. Let's continue watching this video. Just listen very quietly as you consider this question. Put it on your mind. Look into the solution very seriously. Put it down so as to help you in your exam. Now look at this question. C is an organic liquid and D is an inorganic sample. Carry out the following test. Listen, instruction is key in this type of question. Listen to the instructions I'll be giving to you. Let's move on to the next slide of the question. Add C and D together. That's the first question. Take note of that. Add D and C together. Let's see the next one. Now, to the solution above. That is, the solution in which you have added D and C together, add 10% sodium hydroxide and warm. Apply gentle heat. Now, after you have added that, take another quantity of C. Add acidified K2Cr2O7. Do you understand that? Now, after you have had acidified K2Cr2O7, you give the observation as well as the inference. Now, you also take some quantity of C, add toluene's reagent. Toluene's reagent is the addition of AgNO3, NaOH, and NH3. But in case you don't see toluene's reagent, you see AgNO3, NaOH, and ammonia, the same function, the same observation and inference you will see. Let's move on. Look at this. Test, observation, inference. When we added C and D together, D dissolves to give a brown solution. Look at the inference. It shows that C could be an alkanol, C could be an alkana, or C could be an alkanone. If you don't write alkanone, you could write ketone. It's either ketone or alkanone is present. Now, C plus D, in short, the whole sample above here plus 10% NaOH plus warm or plus heat, you have light yellow precipitate. Light yellow precipitate. And that light yellow has a medical smell. If you don't write medical smell, you can write it has an aesthetic odor. It's either you write medical smell, like that of a bandage on the wound, or an aesthetic odor. Let's move on to the next one. Now, when you add C, when you add a portion of C to acidified K2Cr2O7, the color of K2Cr2O7 is orange. Check the one you are using in your center. It's either orange or yellow. But whether orange or yellow, the color changes to green. It shows that a reducing agent is present. Now, when you take C, some quantity of C, plus AgNO3, plus NaOH, there is no visible reaction. It shows that an alkana is absent. Obviously, alkana is absent. Ethanol is present. And when we talk of ethanol, we have three categories: the primary, secondary, and tertiary. But the ethanol that is present here must when you talk of alkanol, we have three categories. So it's either you have ethanol here or a secondary alkanol should be present. But a tertiary alkanol is not here. So just follow the inference here. You will be good to go. Now, let us take the second part. Take D, divide it into three portions. Put the first portion in a test tube and heat it strongly. Do you get that now? Now, put the second portion in a test tube, add H2SO4. Heat and add HNO3 followed by AgNO3 and finally NH3. I told you HNO3, AgNO3 and NH3 put together is called toluene's reagent. So please put this on your mind and try as much as possible to learn it again and again. Let's take the next slide here and see what it gives us. Look at the table. The table is talking about the portion of D plus sodium hydroxide plus heat. Now the observation is going to be a yellow precipitate. Obviously, you see a yellow precipitate. And that yellow precipitate is going to give us an anesthetic smell. Do you get that? Now, when it gives the anesthetic smell, when you take D again, that is the third portion, that is C plus D, is going to give you alkana, alkanol, or alkanone present. Now, take D, heat it strongly. When you heat D strongly, a violent fume, irritating smell, brownish in color. It's not written here, but it should be part of it. Brownish in color. It turns moist or damp blue litmus paper red and then bleaches it. It shows that iodine is present. Now, when you take D plus H2SO4, you add HNO3 plus AgNO3 plus NH3, or you just add toluene's reagent here. There will be a violent fume, irritating smell. Now, look at it. Let's take it one by one. When you add HNO3 directly to this, there will be no visible reaction. When you add AgNO3, that is when you have yellow precipitate. When you add, good day to my beautiful online students. Here come another day of chemistry practical. So please, let your chemical equations be balanced and you'll be good to go. Now, I have done, or I am doing presently, or we are going to watch here, test observation and inference that will help you in external exam. So please, don't take it for granted. Watch it from beginning to the end. Put your question in the comment side and you'll be good to go. Everything we are doing here, there are assumptions of what would come out, and some of them have been proven, some of them have been tested. So it is not as if it's going to come the same way, but in the same vein. You have to learn from this. And if there is anything, it's not all perfect. But if there is anything to be corrected, put it in the comment side. Then I will look into it. Thank you. Let us go on a short break.
I just want to pick this slide one more time. And I want you to understand that repetition is a way of laying emphasis. So let your chemical equation be balanced as you listen to this slide one more time. When you take a sample of D, you add H2SO4, dilute H2SO4, violent brown fume. There is no brown here, but brown is there, supposed to be there. Brown fume shows that I minus from I2 is present. The smell is irritating. When you add HNO3, look at it, there is no visible reaction. When you add AgNO3, you have yellow precipitate. When you add ammonia, NH3, the yellow precipitate is insoluble. That's why we wrote here precipitate insoluble. It is when you add ammonia that the precipitate becomes insoluble that you confirm the presence of iodine ion. But in place of all these, as soon as you add H2SO4 plus toluene's reagent, what you are going to have is yellow precipitate, insoluble in excess toluene's reagent. It's also confirmed the presence of iodine solution. So let's move on to the next slide now. Assignment. This work is very important, and I would like you to do it. Send your answer, only your answer, to the comment part, then you'll be good to go. A is a solution. A is a 0.100 mole per dm³ solution of an acid. B is a solution of NaOH containing 2.0 in 250 centimeter cube. Calculate. There are a number of things you will calculate here. Number one, the number of mole in the average titer. The average titer you are using here is 16.00 centimeter cube. Now, second question, calculate the number of mole in the base, number of mole of base in the pipette. You should know the pipette you are using. It could be 25 centimeter cube, it could be 30 centimeter cube, depending on the instrument you are using. The next question here, number of mole ratio of acid to base. The mole ratio, the number of mole ratio, the mole ratio of acid to base in the acid and in the base. You should know the formula to apply. Number of hydrogen ion in the average titer. You should also take note of that and know how to do it. So just put your answer in the comment side, and I will see if they are correct or not and reply you as the time permits. Now look at the second question. There are two assignment questions. The first one I have given, this is the second one. A is 0.5 mole per dm³ of HNO3. Mind you, this HNO3 could be HX. It's not compulsory, it is HNO3. It could be HS. B is 0.55 gram of impure NaOH. This may be YOH in 250 centimeter cube of solution. Calculate. Let us see those things you are supposed to calculate. The amount of HNO3 in the average volume of A that is used. Concentration of B in mole per dm³, concentration of B in gram per dm³, and lastly, the percentage purity. Now watch this video again and again. Commit your heart to it. You will be good to go. I wish you good luck in your exams. Thank you.